can derive a distance formula very easily using Pythagoras' theorem for the distance between 2 points on the xy plane. And you see from the picture here, if I have 2 points, A is x1, y1, B is x2, y2, then I can draw a line connecting both points and then form a triangle, a right-angled triangle, by dropping a perpendicular to the x-axis from B and dropping or taking the line joining A to the y-axis, dropping a perpendicular from A to the y-axis, and then extending that line beyond A. And these two lines intersect at a right angle because one is parallel to the y-axis and the other is parallel to the x-axis. So I get a right-angled triangle, and of course Pythagoras' theorem applies. And so I get the distance. The square of the distance between A and B is the square of the length of the hypotenuse. And I know according to Pythagoras that's the sum of the squares on the other two sides. So we have the length of this side is the difference in the y values. It's y2 minus y1. It's the same as the length along the y-axis between y2 and y1. And notice I'm using the absolute value here because when labeling the points we may not know which y value is larger. So I'm using the absolute value here. And the length of this side of the triangle is the larger x value minus the smaller one. So that's the absolute value of the difference between the x values. And the reason, of course, is because the side of this triangle is the same length as this line, which is parallel to it. The length of this line, which is parallel to it, that is the line joining x1 and x2. So Pythagoras says that the square on the hypotenuse equals the sum of the squares on the other two sides. So y1, y2 minus y1, its absolute value squared, which is just itself squared, plus the absolute value of x2 minus x1 squared equals the distance between A and B squared, using this symbol for the distance between A and B. And this tells me, taking the square root of both sides, that the distance between A and B is the square root of this. And of course I can drop the absolute values there because the square of the absolute values is just the square of the number plus x2 minus x1 squared. So the distance between A and B is the square root of the sum of the squares of the differences in the y values plus the differences in the x values. Let's check these 2 points. The distance between P and Q here, well, I first assign x1, y1, x2, y2, and because we used absolute values to derive this formula, it doesn't matter whether y2 is larger than y1 or vice versa. My formula says that that's the square root of x2 minus x1 squared plus y2 minus y1 squared. And the rest, of course, are details. This is the square root of 1 minus 2 squared plus y2 minus y1, which is 1 minus 1 squared. Now we have to be careful with this minus 2. So this is equal to 1 plus 2 squared plus 0 squared, which is the square root of 3 squared plus 0 squared, which is the square root of 9. And we're looking at the positive square root here, so that's 3. What about the points P0, 1 and Q minus 3, 4? Well, you should try this problem and then look at the solution later. Again, we have our formula. And we should label our points x1, y1, x2, y2. Doesn't matter which one becomes x1, y1, but it does matter that you keep the x1 with the y1 and the x2 with the y2. And now filling in the details, we have x2 is minus 3 minus x1, which is 0 squared, plus y2 is 4 minus y1 is 1 squared. So now I have the square root of minus 3 squared, which is 9, plus 3 squared, which is also 9. So this is the square root of 18, which is the square root of 2 times 9, which is the square root of 2 times 3. And that's my distance between P and Q.